Hi everyone, I'm Shubham Jhanwar. We are discussing KVPY 2017 SX and the question for this video is this. 32 persons x1, x2 up till x32 are randomly seated around a circular table at equal intervals. Two persons xi and xj are said to be within earshot of each other. If there are at most 3 persons between them on the minor arc joining xi and xj, the probability that x1 and x2 are within earshot of each other is. So here this nr in this rounded brackets represents ncr, which is n factorial divided by n minus r factorial, and this has been used in the options. That's why this has been given. It's a single correct type question. Let's solve it. So here what is the total number of outcomes? Total number of outcomes is essentially the number of ways in which you can arrange these 32 people on a round table, so to speak, or circular table. So that will be what? 31 factorial. And what about favorable cases? Yeah, so favorable outcomes would be such that x1 and x2, between these two people, x1 and x2, at most 3 people are there. Yeah, it can be 0 number of people or 1 or 2 or 3. Yeah. So to get favorable number of outcomes, first let's arrange the remaining 30 people on this circular table, which will be 29 factorial ways. Now, having arranged these 30 people, x1 can be put between any of these between any 2 people out of these 30 people. So there will be 30 gaps. It's a circular arrangement, circular table, 30 people have been put, so there are 30 gaps. So in those 30 gaps, x1 can be put in any of those 30 gaps. So let's say these red crosses, these are the 30 people who have been arranged. Now you may say that only 6 crosses are appearing here. Yes, there will be 30 such crosses. I've just shown 6 crosses, and let's say x1 has been put here someplace. Among these 30 gaps, x1 would be put. Let's say it is here. Now, corresponding to every such arrangement, what will be the number of ways of putting x2? It will essentially be 8. How? Here is x1, so x2 can be here. So there are 3 people between x1 and x2, or it can be here 2 people only, or 1 person only, or maybe no person. Similarly, x2 can be here, no person between them, 1 person between x1 and x2, 2 persons between x1 and x2, 3 persons between x1 and x2. So there are total 8 ways in which you can put x2 corresponding to every arrangement of the 30 people other than x1 and x2, and corresponding to every placement of x1. That means corresponding to every such cumulative arrangement of 31 people other than x2 can be placed in 8 ways. So this is the total number of favorable outcomes. So what about the probability? The probability is number of favorable outcomes, which is 29 factorial times 30, which is essentially 30 factorial times 8, divided by total number of outcomes, which is favorable number of outcomes divided by total number of outcomes, the 31 factorial. If you see carefully, this 30 factorial will cancel out and you will get 31 below. Essentially 8 by 31 is the answer. C is the answer. Thanks for listening.